In section 6, we are going to share with you how one company that had purchased software prior to developing the part number program, we were able to accomplish the first field assignment, which is the commodity code or the family code. But because of the restrictions of the record layout of the part number itself, and here again, we were restricted to an 8-digit part number. We were also restricted to approximately 28 digits in a description, very similar to Section 5, the bearings that we went through. How we were able to integrate 3 separate commodity codes into one commodity code number. And this, I believe, is worthwhile exploring because it indicates the flexibility that you can provide yourself with if you lay out the part number program properly first, and then plan how you're going to execute the development of the part numbers. So in this case, we're going to show 3 different commodities. Commodity 01 is abrasives, commodity 16 are hand tools, and commodity 59 are motors, clutches, and tachometers. Now, in addition to this, what we're also going to do is show you that the field numbers do not all have to be the same. We're also going to show you how you can use the alpha code to expand the number of subclassifications with a limited size part number. So again, like we have done before, we're showing you the storeroom material cross-reference list between the first field, numeric first field, and then its description. And like I did in the previous section 5, I've circled the 3 commodity codes that are an integral part of this section 6. 01 abrasives, 16 hand tools and parts, and 59 motors, clutches, and tachometers. Now, starting off with page number 2, we have commodity code 01, abrasives. Now, in this case, the second field is 1 digit, and that happens to be digit number 3. And here we show the different types of abrasives. When this company first started to develop its part number format and criteria, and remember, the format is field size. The criteria is what does the field represent in terminology. They started off with a numeric number for the second field. And lo and behold, they ran out of numbers because a 1 field, using numeric, you go from 0 to 9. So what they had to do, because of the restriction for the length of the part number, we used alpha. So you will notice the second field, which is the 3rd digit of the part number, we start off with cloth belts, which is A, and then we get into cloth discs, which is B, and so forth. So this is another example for your analysis and perusal where it's a good case of using an alpha character in lieu of trying to have straight numeric numbers. The 3rd field is the grit relative to abrasives. Since the grit number did not exceed 3 digits, then the characters 4, 5, and 6, or the digits 4, 5, and 6, would represent the grit of that particular abrasive. They listed the 5 different grits. Actually, there's 5, excuse me. And there's a note relative to the grit, and it says, if there is no grit shown, and since this is a numeric field, and since this is a part number, we've got to zero fill. So in abrasives, the first field is 2 digits, 0, 1. The second field is 1 digit. The third field is 3 digits. And the last field, digits 7 and 8, is 2 digits, and you notice the term sequential. So if we were to assign the first cloth, let's say abrasive, and it had a 60 grit requirement, the part number would be 01 A 060 01. That's the first 60 grit cloth abrasive assigned. Now the cloths would come in different sizes. Those sizes you'll see are going to be over in the description. Let me walk you through a second illustration. Let's say we have a second cloth abrasive. Then its part number would be 01 A 060 02. You see, we're assigning the last field straight sequentially. So if you lay out the part number plan first, and the plan is part number format, size, and secondly criteria, which is the definition. After it's laid out, you can assign all of the part numbers right from page number 2, which is the part number, format, and criteria page. Now, if we go to page number 3, you're going to see that the definition of the descriptions, format, and criteria is laid out for 01, first field. The second field, since it is alpha, is not zero filled, so the second field is A. And in the major code, we indicate we're in abrasives, and below that we have cloth belts. And you'll notice there is a page number 2, and that page number 2 is the second page for the part number and description series abrasives. Okay? Now, if we turn to page number 4, this is the layout for cloth discs. And again, we have 01B, and again, you'll notice all of the definition relative to how the cloth disc is identified. We have, starting off, diameter in inches, and if there's no diameter, you zero fill. The third digit is always a dash, etc., and etc. So I'm not going to, just try and walk you through this page by page, but I think you've had a very good introduction on the layout of descriptions and the bearing section. And if you follow the same format and criteria and the same succinctness that we're doing here, we go from the high order of definition and the description to the low order, going from left to right, just like we developed the high order and low order definition of the bearings, okay, and the part number. Now, the page number 5, we have the second field, which is C, and that is cloth sheets. And again, we've got the same definition. And I made a comment in the previous section. You're going to have to go through these examples several times. This is not a book to read and then forget about. This is a book that has the format and criteria of unique, I believe, and very high volume commodities that you find in just about every maintenance shop. You must tailor the part number and the description to meet your own requirements. But you should follow the same succinctness that we are showing you in this particular illustration. Going on to page number 6 in the book, we have the disc grinding wheels. And of course, we have the same application for the disc grinding wheels, going from the high order of description to the low order of description. And you will notice the succinctness in terms of the dimensions. They're laid out, item 1 and 2, or character 1 and 2. 3 is always a dash, and then you can continue on reading from left to right. The key is those little arrows have a starting point and they have an ending point. And I'd like to have you take a look at the characters 4, 5, and 6. The description of 4, 5, and 6 is outer diameter in fractions. Okay? 5 is always a slash. 0 fill if fractions are not used. So that means 4 and 6 are going to have dimensions to them in fractions, and 5 is always a slash. So the field size 4, 5, and 6 is developed in terms of the terminology and the definition of what goes into those 3 digits. And I think if you just look at the definition, and if you understand specifically what the person, when that person laid this out, you can't go wrong. And the key is to make it simple. Don't make it complicated where people may have to start asking questions. What do you mean by this? The first time you hear a question asked, what does this mean? Then that means we didn't take enough time to put down the data elements so that person does not have to guess what either the part number or the description represents. Page number 7 is the fiber cutoff discs. And again, we have the same development relative to the description. Continuing on page number 8, we have grinding stones. And again, you will notice that the second field is F. That ties us back with the part number format and criteria page, which is grinding stones. And in this case, the grinding stone is identified by its various descriptive characteristics. When we get into page number 9, we have grinding wheels, different than grinding stones. And again, you'll notice the definition of how the part number is laid out relative to the succinctness of the data that is required for the description. In page number 10, we're talking about sandpaper, and again, you'll notice you could read from left to right, and it will give you precisely the directions that are required, again, for this company relative to the development of the description for sandpaper. In page number 11, we're talking about wire wheels. And this is 01I and not 011. Remember, the second field is alpha. And here again, we have the layout of the definition of wire wheels. Now, that concludes, if you will, the description, the format, the part numbering layout of the abrasive category for this company. Now, I want to go back and share with you some of the data that I referred to a moment ago relative to its part number format. The first field is 2 digits. Now, that's going to be true and consistent for this company's first field. The abrasive second field was 1 digit. The second field was the grit. That was 3 digits. The last field, assigned straight sequentially, was 2 digits. Now, we're going to move to a new commodity called hand tools and parts. And this is on page number 12. And you'll notice that in this case, the first field is 16. Now, notice the second field. It's 2 digits. It's not 1. And the third field is 2 digits and not 3, as we had in the abrasives first field 01. And the last 2 digits is assigned straight sequentially. Now, in this case, there are several types of hand tools and parts. So you will notice, starting with the second field, digits 3 and 4, 01 is air, and the third field, or I would call that the second subclassification, represents the style of that particular type. Now, this type and style terminology was selected by this company. And for air tools, we have drill motors, hammers, nailers, and wrenches. And they start out very easily, 01, 02, 03, and 04. If I go to drill bits, which is 02 in the second field, you notice we have concrete, metal, we have reamers, and then we have wood. Again, they start off with 01, 02, 03, and 04. Now, the 01 for drill motors is not a duplication of 01 for concrete. What makes those digits unique to themselves is the second field, 01 is air, and 02 is drill bits. So don't make the mistake that some companies do when they have a second subclassification, which in this case is the third field, digits 5 and 6. What the companies do that make mistakes, when they go down to 02 drill bits, and I put down the concrete drill bit in the third field, they'll start that third field with 05. They make the assumption that I have to run the third field straight sequentially. That's a wrong decision. The same thing when I look at the sequential number. If I have only 2 drill motors and they're different by description, then the drill motor would be 16, 01, 01, and the first sequential number would be 01. If I went to a hammer and only had, let's say, 1 or 2 hammers, then the hammer would be 16, 01, 02. Now I'm going to go back to 01 again. Don't run the sequential numbers sequentially, because at some point in time what's going to happen is you're going to run out of numbers, and you're going to wonder, why are we running out of numbers? It's because we're not following the logic that each time I go to a different field, I can reuse numbers all over again, because those are independent of each other. Now, if we continue on hand tools, on page number 15, we will look at the second field, 05, saws, circular and saw blades, and then we get into 06, sockets and accessories and so forth. And you notice the same continuation occurs. And then when we're down at the bottom of this page, we have 99 miscellaneous. Here again, this company has obsolete inventory, like most of us do if we don't have a good inventory and a part numbering system. And anything that we can't identify will have the part number 1699 associated with it. And like we talked about previously, those items at some point in time after the part numbering system is complete should be removed from the storeroom, and we should determine whether the item is a legitimate item. If it's truly obsolete, then we should have final disposition made for that particular item. Continuing on Now we're going to go over to the description. Now some of these pages are not complete, and this is a building block approach. So I'm not going to try and indicate that every company has all of their part numbering descriptions complete as they get started. Some may just be held in abeyance, but if you notice on page number 14, we're talking about the air tools, which is 1601, and here is a basic note. List as required, starting with digit 1. There's nothing wrong with a notation like that. We call that free-forming. Free-forming says there are no dimensions here. We're going to put some verbiage in here. However, between each word, we're going to leave a blank. Okay, now that is not identified on this page, but that's some of the disciplines that are required when you set up the program. Continuing on page 15, we talk about the drill bits, and again, this is the definition of the various drill bits. And I'm going to just kind of walk you through this. We get into the electrical hand tools, and again, there's the complete layout relative to the hand tools. We get into hammers, which is the next page, and there is a definition in terms of how they want to identify their hammers, which is the second field 04. Continuing on with circular saws and saw blades, which is page number 18, we have the layout relative to the description and its particular format and criteria. Continuing on, we have sockets and accessories. And again, I'm not trying to rush through these exhibits. I don't think you want to sit there and let me walk you through word by word. I am trying to highlight the key data elements, and what you should do is to go through these page by page, item by item, until you thoroughly understand how this company developed the description relative to the subject, relative to the format, and its related criteria. Continuing on page 20, we have taps and dies. Now, in some cases where we have commodities that are universal, drills, taps and dies, hammers, other types of tools and accessories, some of the part number aids that I have in section 10 can be developed in front of the part numbering program. And you could use some of the industry standard terminology if that's the way you identify those particular commodities within your maintenance shop. But if your maintenance shop has its own characteristic of lingo, their own style in terms of identifying an item, then you're going to have to use your own style. Let me give you something that I've run into, and it's so simple. A washer is a washer to most of us. But do you know what that item is called in some shops? A donut. You know what it's called in other shops? A spacer. So I don't care whether you call it a donut, a spacer, or a washer. If that's inherent in your shop, call it the way the people in the maintenance organization identify to it. You don't want to change, as I said earlier, the language of the shop. Make sure that the part number and its description is going to be usable by the maintenance people, because those are the individuals that are really going to use the part number program. Now, we get into wrenches, which is on page 21. And again, there's all of the detail for you. The next page, we're talking about yard tools. And again, they basically say list as required. In other words, How do we call different yard tools? Picks, axes, shovels, things that are not integral to spare parts, but things that are integral to maintenance tooling requirements. Now that concludes the Commodity Code 16, tools and accessories, or tools and parts. Now I want to show you what this company had to do relative to a limited size part number and a limited size description. The next page, which is page number 23, addresses 3 individual commodity codes. Motors is a major commodity. Clutches is a major commodity. And tachometers is a major commodity. But because of the limitation of 8 digits in the part number and 28 digits in the description, we had to ask ourselves what commodities work together. In other words, what commodities are kind of working with each other relative to not only maintenance requirements, but from an operational standpoint. And what the company came up with is the following. They put motors, clutches, and tachometers into one commodity code called 59. Now when you do that, 59 by itself addresses 3 major commodities. So I think it becomes quite apparent that the second field, and in this case the second field is 1 digit, and the second field addresses a number for a motor, it addresses a number for clutches, and it addresses a number for tachometers, and guess what those numbers are? Very simple, 1, 2, and 3. So we're able to, with these 3 major commodities, put those into a single commodity code 59, and 59.1 is motors, 59.2 is clutches, and 59.3 is tachometers. So in essence, I'm using a 1-digit first field, 59, but I'm supporting the part numbering system by the second field using 3 major commodity codes. This, I have to admit, is a rarity. This is one of the first times I've run into it, but I've run into it many times since. Now the third field here is 1 digit. If you go back to the abrasives and to the tools and so forth, you'll notice that the field sizes are different here. And that's why I selected these 3 commodities for this particular company. We are very flexible in part number layout. The fourth field is 1 digit. And guess what? The first, second, third, and fourth field just about gives us all of the characters that we need to identify part numbers. So therefore, the last field, digits 6, 7, and 8, are going to be used in straight sequential. And if you take a look at motors as an example, we have 2 types, AC and DC. Well, in this case, since they want to stay straight numeric with the other sub-classifications for clutches and tachometers, they decided to say 1 is AC and 2 is DC. And what is the reasoning? A precedes D. Therefore, A is 1 and D is 2. I think it makes a little sense. And the third field is the type of motor. And then we go down into clutches, and we have the 4 different types of clutches. And since there is no type for clutches, they zero fill it. And then we would go ahead and assign the straight sequential numbers and continue onward. Now, moving on to page number 24, we're going to get into the development of the description for motors. So the first thing we have to address is in the upper right-hand corner, first field is 59. The second field is one digit, and that's 1, and that addresses motors. And here is the layout, if you will, starting off with the horsepower of the motor. And then we get into fractions of the horsepower. And item number 9 is always a dash. The letters 10 and 11 are always HP. We have 28 digits. We got to do some abbreviation. And then we continue onward. When you look at digits 22, 23, and 24, those are the motor frame numbers and so forth. This, again, is tailored to the specific user. We continue on with motors, and you know, I indicated that we were restricted with 28 digits originally, and when we were in the previous section 5 on bearings, right near the end of the bearing section, we showed a second field size going from digits 29 to 56. Here again is another illustration of where we had to expand the description so that we can truly develop the significance of the description relative to motors. So in this case, the page number up on the title is page 2A, which means that the previous page of description is 2, and this page is 2A, which is found on page 25. So pages 24 and 25 in a notebook are kind of linked together with the item master record of the description going from digit 1 all the way through digit 56. Going to the next field, we're talking about clutches. So this is 59-2. And in this particular case, clutches has its own derivation relative to the definition of the description, and I think that's laid out for your ease of reading and interpretation. And the last page in this section is tachometers, and you'll notice they identify the tachometers very simply by the voltage of the type, and here's where they get into different types of tachometers where they're using VAC or VDC, which is DC or AC type voltage, and then after the voltage after the voltage, I should say, they indicate or count, and that happens to be the tachometer method of accumulating either hours of production or quantity produced, and that would have to be finalized into the balance of the description. The thing that I was trying to do with this section number 6 is to indicate to you, like I've said previously, that field sizes do not have to be the same. You tailor the part number to the specific commodity. And it also in this case, where we are kind of limited with part number field sizes, that we've shown you how a company can take 3 major commodities, and because of their functionality in use, we can put those together, and we can very easily separate them by using the second field to identify each one of those commodities. And again, I don't expect you the first time going through the tape or through the notebook that you're going to become an expert in part numbers. As I've said before, you're going to have to go through this again and again. I've been developing part numbers on the production side for over 30 years. I've been developing part numbers in the maintenance side in excess of 30 years. And you know what? Every new client situation I learn. Why? Because the client has unique characteristics. Therefore, use the data in the notebook to help identify what your characteristics are. Now what we're going to do is we're going to move into section number 7, and we're going to be talking about some other applications relative to part number development for some other common commodities that may be of interest to you. Section 7 is another illustration of a company's part number program. And again, this is in the notebook and in the tape for your perusal, for your educational purposes. What we're going to be looking at are part numbers for conduit, pipe, and tray, connectors, terminal blocks, plugs, switches, and receptacles. And on the next page in your notebook, I've identified what the commodity code numbers are for these particular items. And you'll notice here that we have commodity codes for the conduit, pipe, and tray as 49, and we have commodity code 50 for connectors, terminal blocks, plugs, switches, and receptacles. And this is just another illustration to indicate how you can blend many different subclassifications into one commodity code. My advice is try not and give commodity codes to subclassifications like connectors, terminal blocks, plugs, switches, and receptacles. If you did that, you're going to use up 6 commodity codes for those items where we've only used one commodity code 50. And again, you may find that, well, Frank, it's nice, I hear you, but I'd like to have individual commodity codes for each of those commodities. Then my advice is to consider a 3-digit first field. You're not going to do it with 2 digits. Now, again, starting off with page number 1, using the same cross-reference between the first field and the definition of the first field, I have circled commodity code 49 and 50. Now, in this case, you'll notice that rather than have numeric page numbers, I'm trying to tie in these commodities through the definition of page 1 of 3, page 2 of 3, and page 3 of 3. And then when we get into the next section, we'll have page 1 of 7 and 2 of 7 and so forth. So in this case, what we're doing is we're saying 49 is conduit, pipe, and tray. And the second field in this case is a 2-digit number, digits 3 and 4, and those are the material requirements for the conduit, pipe, and tray. The third field of 2 digits indicates the OD range. Now, previously I said you don't want to have dimensions in the part number. These are not dimensions. These are a range of dimensions. And again, because of limited field sizes, this was the only alternative that can be taken. But when I look at 01 in the third field under the OD range, 01 is 1 inch or less. So if I have something that's 3/4 of an inch, I know automatically that the third field is 01, so I'm going to go over to the description and look at all of the sizes that are under 1 inch, and I could pick out the specific description based upon the 3/4 inch. I come back to the fourth field, which are digits 7 and 8, and that would conclude, if you will, the total 8-digit part number. So when I have a description and I know the specific dimension is in the description, I can go to the part number format and criteria, and it would lead me to that specific end part characteristic, which is the last field, and it is always assigned straight sequential. So going to page 2 of 3, we have the description for conduit pipe. And this is very simple. We have the diameter in inches, and if it's not used, you zero fill. There's always a dash. Then we have the diameter in fractions, and then digit 6 is a slant, okay? And then, is an X. It's always by, and then we have the length in feet, okay? And if you wanted to, you could put other, definition based upon the furthering, expanding the description. Page 3 of 3, we have tray. And this is the basic definition of the tray. You'll also notice in the upper right-hand corner, we're addressing 4902. That's the second field, okay? And that, in essence, concludes those particular commodities, conduit and tray. Now, the next 7 pages will address the connectors, the terminal blocks, the plugs, the switches, and receptacles. So we're going to start off with the first field of 50. But in the second field, we have a 2-digit number. And you'll notice that the second field is addressing the particular classification of connector, terminal blocks, plugs, switches, and receptacles. So just like the motors and tachometers in the previous section, here again, we can commingle items that are either functionally used together or items that are functionally used in a manufacturing or in a process. Here, they're used together by craft. So in this case, connectors, the second field, 01, and we use now the third field, a 2-digit number, and we have the style of the connector, of which there are 4, 01 to 4. When we talk about plugs, there are 5, and you notice we go back, use 01 again, and we have 5 different types of plugs, and then we get into the receptacles, we get into the switches, and the fourth field, which are digits 7 and 8, are assigned straight sequential. Going to page 2 of 7, we have the terminals, which now concludes all of the items that we have in our major category. And then the bottom item, item number 999, miscellaneous, is there for those items that are basically obsolete. Now I want to continue for page 3 of 7, and we're going to move over into the description. And again, the description now is for connectors. So you notice under major code, we have the entire terminology of all of those subclasses or major subclasses within commodity code 50. And since connectors is 01, the second field, we show that particular second field number, and then we get into the development of the terminology based upon the description. The next page, 4 of 7, is for plugs. And here again we have 5902, and we go into the development of the individual plug descriptions. The next page, which is a definition of the receptacles, which is 5003. We go into the development of the format and criteria of the receptacles, and the next page, which is 6 of 7, goes into the switches. And again, you notice that the second field is 04. That cross-references back to the individual part number layout. And here again, we're indicating how that particular item is developed as far as description is concerned. And the last page is 7 of 7, and that is for terminal blocks. And you notice here the vendor catalog number starting with digit 1. Example, they buy terminal blocks from a specific manufacturer. So in this case, they know who the manufacturer is, so it doesn't make sense, and especially when we're in a condensed description layout, 28 digits, it doesn't make sense to put the supplier name in there, so they put the part number. So in essence, what they're doing in the description is they're cross-referencing their new part number with the vendor part number. Now, if I wanted to go to the purchasing record for that item, I'd know who the supplier is and all of the other supplier information, okay? So in conclusion, with section number 7, we're showing you additional variations of how a part numbering system provides the flexibility. Many people think that your hands are strapped, you can't, utilize flexibility. As I told you in section 1, part numbers are unique to you. Uniqueness to you says you've got the flexibility, but make certain that you are consistent when you develop the layout, which is the format and the criteria of both the part number and its description. Now what we're going to do is to go into section number 8. And in section 8, we're going to show you how a 100% indicative part numbering system is developed. As I indicated a moment ago, section 8 is an illustration of an indicative part numbering system. And in this title page, I indicate that this section contains items that have an indicative part numbering system. The part number is generated from the part number matrix. In other words, we're really not talking about the development of a format and criteria for a part number and format and criteria for a description. What we're doing is we're going to have one document that will give us the capability of developing part numbers, and as many as there are relative to the data that goes into the matrix, and the description as an integral part of the form. So if you would turn to page number 1, and there are approximately 12 different exhibits in this section, and they each pertain to individual commodities. As an example, the first commodity is for angles. Now, this company, and this was kind of a prototype for them, wanted to develop a part numbering system, and we naturally got involved and gave them the support and the guidance and et cetera and et cetera. And they thought it would be very propitious to include a diagram of what the item looked like. So in your notebook, you'll notice in the upper right-hand corner, there is a little diagram of what that item is. In this case, we're talking angles. Now, down at the bottom is the description for angles. And the first field going left to right is the series. Now, they don't use commodity code. They call it a series. So 001 is the raw material, okay? The part name, AN, is the angle. See, so we're going to start using abbreviations. The material, 001, in that third field, this happens to be M1020 hard rolled steel. And when we get into the next field, the length, number 1, and that would be one side of the angle, that's 250, and in this case, that's 2.5 inches. When we get to the other side of the angle, length number 2, 200 is 2 inches. And then in this case, we're trying to use a conversion between the decimal equivalent and fractions, so a 3/16 inch thickness is 19. So we're pulling all of this data together up into the part number. Now, we're not zero filling here, okay? But 001-AN001-250-200-19 is a 100% indicative part number for this particular commodity. Up on the top, they indicate what an example of a description would look like. When you set up a indicative part numbering system like this, you've got to be 100% in succinct. In other words, it's got to be by the numbers. And you have to go from left to right. And if you have a series of different dimensions, you have to indicate what the dimensions are from the lowest to the highest. Because if you don't have the lowest to the highest, which are the parameters, then people may develop part numbers that have lower dimensions or higher dimensions that is not in the integral part of your part number program, and you're going to develop erroneous, okay, part numbers. Now, to get you started, if you turn to page 2, you'll see that in this particular exhibit, we're talking about flat bars, okay? And again, you notice we have raw material, and the next one is what is a description. FB is flat bar. Now, in this case, we got two types of material, 001 and 002. And then we get into the specific alloy definition of that material. 1018, which is AISI 1018 steel, and the other one, SAE 8515, is the red brass. Now, here's the range of dimensions. There are no lower ranges than 3/8 of an inch, and there are no higher ranges than 4 inches. You'll notice, and it doesn't say it here, but we have the ability to incrementally and thickness go up 1/8 of an inch. And then we have the width, and we can go from 3/4 of an inch to 14 3/4 of an inch, and that is by increments of 3/4 of an inch. So here again, with two different materials, we can develop a very highly indicative part numbering system. Continuing to page number 3, we get into a commodity called round bars. Now, in this particular case, looking at the design, we have 6 different materials. You look at the material types, okay? I'm sorry, I want to go back. The design are the different types of round bars, and the materials in this case are identified in the 4th field. And in the 5th and last field on the right, we have the individual sizes. Now, if the type of design and the material is not identified, and if there's something that you want to select outside of that range again, going from 1/4 down to 10 inches, there's no way that the part numbering system would accept it. So again, I could create many, many part numbers from this particular application. 001 RB. I could have from there 001, 002, all the way up to 006. And for each one of those, I may have different materials. And for those, I can have different, if you will, dimensions tied in. Continuing to page number 4, here we have round tube stock. And again, we've got the same type of a layout, okay? You see, I can develop the part number from this particular exhibit. And that's what indicative means. I can develop the part number, which is 100% indicative. It says every field means something from the beginning to the end. If we get into the next element, we have what we call round bars, or round blanks, excuse me. And here again, we have three different raw materials. We have three different methods in which the round blank is actually manufactured. And then we have the thickness, and then we have the diameter. And again, we've got limits in both or ranges within the thickness and the diameter. The next element is something that most of the people in the pipe shop would understand. And these happen to be elbows. In this particular case, we have three different types of material of elbows. We have different elbows in the fourth column here from 0,1 to 0,5, 90 degree, 45 degree, etc. We have three different PSIs, and then we have the nominal size in terms of the ID relative to the elbow. So we can develop all of our part numbers from this particular exhibit. Here is something interesting. If I multiply each one of these fields by the number of items that are in there, that'll tell me how many part numbers I can generate. And I'm just going to do this one time on this one exhibit. As an illustration, the series I have one elbow, so 1 times 1 is 1. I have 3 materials, so now I have 3. I have 5 different designs. Now I have 3 times 5 is 15. I have 3 different pressure ratings. Now I have 45. And then I multiply that by the various sizes here, which are, let's see, 4, 8, there's about 11 or 12. I take 45 times 11 or 12, let's say 10, round it out. 450 different part numbers right from this exhibit, the matrix. Now that's the nice thing about an indicative part numbering system. But it's very hard to put together and maintain, especially if you have random dimensions and they don't fall within 1/2 of an inch of each other and so forth. So the part numbering program relative to indicativeness, uniformity in terms of dimension characteristics, the OD, the ID, where there's uniformity in terms of graduation. Excuse me, the balance of the exhibits, and I'm going to let you go through those at your leisure, follow the same format. They're self-explanatory. They're in basic English. They're in dimension format, and you read from left to right. I have worked with just a few companies that wanted to go into 100% indicativeness. And I think other than the one where I'm showing you the illustration, the rest of them all moved back to the creation of part number and descriptions as we have been discussing in previous formats. Now, the next section, in section 9, is going to be some homework for you, and I'm going to walk you through a couple of the illustrations and show you what we want you to do relative to homework. And then section 10, as I said earlier, are the part numbering aids. And this is just, I think there are 10 different aids in there, so you know what a part numbering aid is and how it's used. As I indicated a moment ago, in section 9, we're going to have you do a workshop example. And there are actually 8 workshop examples that you're going to work through. It's very simple, and I'm going to give you the introduction relative to how you're going to proceed in the workshop, and all you have to do is to write down numeric numbers from 1 to whatever or how many different criteria we have relative to the specific commodities. As an example, let's go to page 1. We have overhead cranes. Now, we want you to design a part number for an overhead crane, but I don't want you to spend the time to determine how many digits are in a field and how, big the field should be and what the field should represent. What I want you to do is to consider from the highest order of identification to the lowest order of identification by a numeric number. Now, in this case, we have 7 items of characteristic of a crane. The highest order of characteristic should be identified by 1. That's the highest order. The least order of characteristic should be identified by 7. So what I want you to do is to look at this overhead crane classification and determine what is the first thing that is going to be extremely important about the overhead crane. Now, in some of these commodities, there may be 1 or 2 answers to the particular part number layout. However, in some of these, like the overhead crane, there's only one way, which is the correct answer. And we don't have multiple choice here. So what we want you to do is to maybe do some research. Maybe what you want to do is to get a catalog on overhead cranes and see how a manufacturer of overhead cranes identifies these issues. Now, there may be other issues, other item characteristics that may be in a catalog. I'm only interested in these 7. So randomly, whether you put it to the left of the individual items or you put them over here to the right, I could care less. But I want you to identify the highest order, starting with 1, the next highest order, the next highest order, so we go 1, 2, 3, all the way down to 7. Okay? Now we're going to look at an item that probably electricians could identify very easily. And this happens to be single pole rocker switches. Now again, what is the highest order of identity relative to a single pole rocker switch? Now, you'll notice there's another element in here down at the bottom, unit pack. I don't care how many are in a container, but is unit pack a high order or a low order of identity relative to the single pole rocker switches? Now, basically what these exercises are trying to provide you with is the ability to logically think on some commodities that are maintenance related, some commodities that are non-maintenance related, as to the order of high order to low order identification. And again, since we have 6 characteristics here, you will identify high order to low order going from 1 to 6. The next item, there is a couple approaches to this, and that's screws. And we use screws in the mechanical shop, in the carpentry shop, and also electricians use screws. So depending upon your background, there could be maybe 2 answers to how we would define screws. And in this case, there are 8 characteristics. So we want to identify the high order to the low order. And in this case, you're going to come out with 1 to 8. And if we go to the next item, which is a non-maintenance related item, but that happens to be shipping cartons. Now, maybe you may want to talk to your shipping department foreman and he could give you some guidance. Don't let anybody do this for you, but you may have to do a little research. And that is good, because now you're starting to think about how, if I design the part numbering system for these commodities, what is really the high order to the low order? We have been using illustrations like this for many years. You can have a lot of fun with this with some of your cohorts back at the shop. Let them do some analysis. But remember, the only way you're going to get the return of your time into doing some of these homework assignments is you've got to put the time and thought into it. Because if you don't do it, you're not going to, develop yourself into be able to maybe spearhead or be an integral part of a part number program. Here's an interesting category, shoes. And again, we want you to look at, as an example, these 6 different characteristics. What is the highest order to the lowest order? So in this case, you're going to go from 1 to 6. You should have a lot of fun with this one. I wonder what gender means. When we go to baseballs and softballs, you'll notice that we have 7 different characteristics here. Now, I'm going to give you a hint on this one. Yes, I have a heart, and I'm compassionate with the people that are going to put a part number program together. Sometimes a part number system is developed not the way we may order something or the way we may perceive something, but maybe the way the item is manufactured. That's a hint. Continuing with ball bearings, this is a good item for the maintenance department. And here again, we have 6 items within this particular commodity, ball bearings. All you have to do is determine what's the highest order to the lowest order of identity and mark down 1 to 6 randomly, depending on your appreciation, if you will, of what the items are in that particular order, high to low. Now, the last one we find in electrical shops, small variable speed motors. And in this case, we have 8 characteristics. I'll also indicate here there could be more than one method to identify high to low order. And in this case, whether you go down one path or the other, remember the path you choose, you have to be consistent on the balance of variable speed motors, because you could have medium and you could have large variable speed motors. So what we do in one major commodity would lead us into doing it the same in other major commodities. So there are 8 individual commodities here. If you have to do some research, do it, as I've said before, because this is the fun part of learning about a part numbering program. Yes, there's a little hard work in putting together a part numbering program. But the end result, believe me, is tremendous. There's tremendous payback. And we want everybody to participate in the development of the part numbering program. Now, what I'm going to do is move into the last section, section number 10. And these are the training aids that I talked about. And I just have a few. I think there's about 10 in here. And you may need more than this. I'm going to at least identify the training aid, tell you where I got it, because you could do the same thing. Most of these are all free. Some you have to kind of hunt and peck and get. But they're used so that we are uniform in the way we're going to identify certain characteristics, not only in the part number, but also in the description. Section number 10, the last section in our part number series, has to do with part number program aids. And I want to at least walk you through the derivation of what I call the part number program aid, and it is as follows. The following pages represent part number program aids to assist in the selection of dimensions, commodity terms, and identification for the development of commodity part numbers and commodity descriptions. These part number program aids come from various source documents. For example, vendor catalogs, industry catalogs, technical maintenance publications, and other source documents to provide guidance in the development of your part numbering program. All people in the part number program should have a complete set of aids to assist in the part number program. Don't have the aids put into one notebook where people have to go up and get the notebook and pick and choose. As you develop new aids, make certain that all the people on the part numbering program get the new aid. If one is going to be replaced by another, you find something a little better, then make certain that the old aids are removed and the new aids are added. Now, I'm going to start off with the first page, and I said there are about 10 different pages relative to the aids. Actually, there are 11. Okay? The first one is a cross-reference of inches to millimeters. I know many of you have both inches and millimeters in your particular crib. We have to identify not only the part numbers, but the dimensions and the sizes. So one of the aids is a standard inch to millimeters conversion. Everyone should have a copy of this. If I look at the second page, I have the conversion of millimeters to inches. So pages 1 and 2 are really the front and back of a particular exhibit that I was able to receive from the company's name that is on the bottom portion. There's no reason why you can't get something like this. And if you need, like I said, 8, 9, 10, depending on how many people are in the part number program, you certainly want to provide a person with each one. Now, page number 3 is the fractions of an inch and decimal equivalents. We all want to look at the fractions and decimal equivalents and have consistency within our program. Again, there's a supplier's name on the bottom that I received this from, and all it takes is a telephone call or maybe talking to a salesperson that is a representative of one of your suppliers, and they will be very happy to assign or provide you with programming part number aids. Now, in this particular example here, we have standard decimal equivalent in inches for various gauges. Gauges are basically for materials, and many times these materials are used in projects, or they can be used where we may do some PMing. Sheet steel, we use a great deal of standard dimensional requirements like this. HVAC piping and ducting and other applications. This is a key byproduct of a dimensional aid where you will have consistency and you'll have accurate conversions. On the next page, on page 5, again, here's another one of decimal and millimeter equivalents. So we're just kind of expanding some of the previous exhibits that we've looked at. On page number 6, this happens to be an index from an electrical supplier. And we use many of our supply houses indexes like this. It doesn't mean we're going to have all of these indexes in our particular maintenance part number program, but it gives us an opportunity to determine how these suppliers identify commodities. And if you remember, if you go back to section 2, page number 3, or document 3, that's the cross-reference between the first field going from 01 to 99, and here is a good illustration of how you could maybe standardize on developing commodity terms. Now, if we go to page number 7, here we have tube fittings, okay? And again, they're different applications, different fittings. I know you're not in a plumbing supply business. You may just use a few of these, but at least it gives you an indication of how a manufacturer of tube fittings addresses their particular items. And the item, most importantly, is tied in with some physical, requirements as opposed to dimensions here. The next page addresses a variation of different pipe fittings, and we have couplings and elbows and T's, and along with the different standard steel pipe dimensions for fluids, linear down at the bottom, and over here in the right we have abrasive paper grades, and over on the top left we have conversions where we're talking about squares, volumes, and capacity. So this exhibit has a mixture of different applications. Going to page number 9, we're talking about retaining rings. And this just happens to be one series of retaining rings. There are many different retaining rings. I don't expect you to go out and get every retaining ring manufacturer's or supplier's catalogs, but get those that are part of your part number program, those that are currently in your storeroom, that are currently in your maintenance system. On the next page, page number 10, we have some additional information relative to retaining rings. And you'll notice that these two pages, pages 9 and 10, came out of a maintenance publication. So that information is being provided to us free. And we should use that information, especially when we're designing our part number program. Now the last page, page number 11, I always get a big bang when I look at this particular page. It comes from our old original source, Popular Mechanics. And guess what it's called? A shop guide. And it's a metric conversion chart. And it gives us the different dimensions relative to screws. We can get into another illustration, which we don't have in here, of different head configurations. Here we have different nails. Over here we have standard lumber sizes. So we've got a combination of different commodities. What I'm asking you to do is to help yourself. Get the training aids first, and probably continue to get training aids while you're going through your part number program. This concludes the part number program for the maintenance organization. What we've tried to do is to provide you with the details on how to establish the part number program, provide you with the forms, give you the know-how to the best of our ability, and show you what some companies have done relative to developing part numbers. And what I really tried to do was to give you illustrations of where we had to work with constrained part number field sizes and description field sizes. And I used to kind of shy away from those restricted field sizes. And one of my clients said, Frank, you know, I think you ought to show people what you and your clients were able to do when you were constrained. Because if you can work in a constrained environment, isn't it easier than working when it's easier to work in an unconstrained environment? And you know, I learn every day from people that give me good advice. So that's why we put some of these constrained conditions into the notebook. If we could do it in a constrained environment, imagine what we could do in an unconstrained environment. And we wish you a great deal of success in your new part numbering and description program. Thank you very much.